once SLS is ready and once the test flights have begun, you guys have talked about doing the mission of, doing pretty much an Apollo 8 style mission with astronauts on board. But what I find interesting is some of the other design architectures that you guys have had of where to go. For example, your Plymouth Rock mission, combining the two Orions together to have the habitation and going, and also the whole idea of having the mission on the far side of the moon and doing the telerobotics there. Can you tell me a little bit more about those ideas and what kind of traction they've gained at NASA?
Sure. I guess our first stepping stones concept, and this isn't new and necessarily Lockheed, but a community of folks, NASA, industry, and science community, saying when we do exploration, we want to go further and longer, but in a stepping stone fashion, so we can understand, before we go too far, what the risks are, and make sure the systems are working. So the moon is a logical near-term destination. And we've been to the moon. People say we've been to the moon. We've been to the near side of the moon, but we have not been to the far side of the moon. It's an unexplored territory other than mapping. We know what's back there, but we've never been there. We never can see it unless we're orbiting it. And we can only orbit it with the Apollo-style mission. With Orion now, we have the capability to send that to the Earth-Moon L2 point, Lagrange point, that's on the far side, and we can put the spacecraft into a halo orbit so that it can see the far side of the moon constantly and Earth at the same time. So we can do communications between the Earth and the spacecraft, and then the spacecraft to the far side of the moon. That now allows the humans in the capsule to telerobotically operate a rover and do certain things. We can gather samples on the very interesting Aitken Basin where the good samples are on the moon, and deploy radio telescope technologies that will allow us to look into the clear radio quiet sky and really explore the dark ages that are really unknown today. We know they existed, we don't know what happened after the Big Bang. So we can now look into that realm and understand it better very affordably. We don't have to send boots on the ground, but still humans are required. It would be very difficult to do telerobotically from Earth to a relay station. So having the crew there and virtually real time operating a rover is invaluable. The next step is going on to an asteroid. Now we've identified several opportunities. One is actually in 2019 that we could get to. It could be a 6-month mission. We've using NASA standards for habitable volume, you'd probably need the volume of 2 Orions, and so we show a picture as a graphic. But you definitely need the capsule and you need some habitable volume. It could be a habitat. Another great opportunity for international collaboration, or within the community, the commercial community, one of their spacecraft, if it was equipped to do the duration and sustain the radiation and micrometeor type environments that are out there. But an orbital Cygnus cargo carrier, for example, would be a nice habitable volume that we could utilize. The capsule part clearly is to get the crew off the planet and back on the planet. And it can sustain life for, on its own, 21 days. But with another habitable volume, you can extend that. And when we eventually go to the moons of Mars and Mars, we'll be sending more habitable space than just the capsule. But the capsule is needed to get us back safely and return through the atmosphere, land in the water, recover the crew. So a lot of opportunities for collaboration. And one of the things Lockheed is trying to do is talk to our national team partners and international partners on where's the best way to do exploration. It's as though we're expanding the space station model, that international collaboration, to the next level, further in space, planetary exploration.
Without mentioning any specific companies or governments in general, have you had good responses to that outreach?
Lots of interest. I think there's a lot, everybody's motivated. I mean, everybody in the industry likes the idea of exploration in space, and it's not a ton of money that this country is spending on space. 0.5% of the national budget goes to NASA. That's not very much, but they get a lot of bang for the buck. So when we talk about it to the community in general, everybody's excited about it, and we need everybody. We really everybody has to collaborate. No one company or no one nation necessarily can do it on their own with the budgets they have.
Absolutely. Yeah. So once Orion is flying and a lot of these missions start to be attained, what do you see the future of Orion being? will it be one of those spacecraft that we use for a particular set of missions like Gemini or Apollo and then retire it? Or do you think that it could be more of a longer lasting vehicle that would be upgraded every so often? And
yeah, the one of the things we've learned in the last 5 decades of building space flight hardware is that it's really nice to be able to do block upgrades, to introduce new technologies. The shuttle really could never experience that. It would have had to go through a really expensive recertification every time we added a new technology, and so they were kind of stuck with 70s technologies for a long time. The Orion program, on the other hand, is designing it from the beginning to be able to introduce new technologies as we go. So we see it as a long-term program that can sustain itself. The vehicle it'll look similar, but it might evolve as avionics and guidance and nav get better, communications, power systems, propulsion. We have the ability to go in and upgrade. It's very modular, very easy to replace and upgrade as we go. So that's the concept, based on 50 years of experience.
Awesome. Well, what would you say is the most important thing that people need to know about Orion and Lockheed in general?
I think it's a great spacecraft. It is taking the latest technologies. It's not developing technologies, but taking the latest technologies that have evolved over the last 50 to 60 years and bringing them all together into a very efficient capsule. All right. Lockheed's committed to work with NASA and others to make this the vehicle of choice to do exploration and do it safely. It's all about safety. It's all about getting crew out there so they can do what they need to do and then get them back safely. So we're spending a lot of time working with NASA and the requirements and understanding exactly what we need to do and how we can verify that it's going to be done, doing that as much on the ground as possible, then through test flights, verifying it's safe, and eventually start flying crew. When NASA chooses, that could be as early as 2017, and right now our first crewed flight is scheduled for 2019. We could move that up earlier if NASA chose to.
Even if NASA didn't choose to or approve to, if, for example, the first flight vehicle that you guys are already building is ready before the 2017 or 2019 date, would at that point you seek either an international or commercial partner to try to launch the mission sooner?
I think those are good discussions to have with folks to understand what are the options and what could you do. So we are in dialogue with other companies about what could be done, but clearly I think the idea, let's focus on SLS, let's get that built and do our test flights as NASA chooses.
Well, is there anything else that you would like to add or share with us today?
Well, just that Lockheed is excited to be working with NASA on exploration. That's our focus. But we want to make it clear that if there's an opportunity to help in any way we can the commercial folks be successful, we're extending our hand to do that.